Okay, so the sub let me know that y'all were having issues with this question on the review, so I wanted to work it out and show you guys how it would work. It's really not bad, but it's just kind of long. So if you start by just sketching out a picture of this well, it's 9 meters deep. So from here to here is 9 meters. And then you would draw like your bucket down here in the well with the string coming up out of the well. So we know that there's a tension force, obviously pulling the bucket out of the well, and then you would have a gravitational force here. I know you guys haven't really done much with free body diagrams, but it would look something like this. You'd have your tension up and Fg going down, that's the weight due to gravity. And tension has to be greater, otherwise it wouldn't be accelerating out of the well. And so to figure out, they give you a time and a distance, so that should clue you in that you have to do kinematics. So looking on your formula chart, the second kinematic formula says x is equal to v sub o t plus 1/2 at squared. And looking at this kinematic formula, you have a distance, so that's x. The initial speed of the bucket, if it's just chilling down there in the well, is 0, so this whole term goes to 0, which means you would have 9 meters is equal to 1/2 of your acceleration times, they give you the time of 3 seconds, squared. So you have 3 squared is 9, half of 9 is 4.5, so you'd have 9 meters is equal to 4.5 times my acceleration. And this unit would be seconds squared, because I squared time. And then if I divide by 4.5, I have an acceleration of 2 meters per second squared. Now that I know that, I can use my F equals ma to solve. So if I know the acceleration, they tell me it's a 20 Newton bucket. That's a weight, and we should hopefully know that weight is equal to mass times gravity, which means 20 newtons is equal to the mass times g, which is 10 meters per second squared on Earth. So that means that the mass of this bucket is only 2 kilograms. So here then I basically have that the net force has to be equal to 2 kilograms times 2 meters per second squared, which means the net force is equal to 4 newtons. So to solve from there, the net force tension minus Fg, so I'd have tension minus Fg since Fg is opposing tension, which means my tension would be equal to Fg plus 4 newtons, and Fg, that's the gravitational force on the bucket, that's 20 newtons. So that's why the tension is actually equal to not just the weight of the bucket, which is 20, but 20 plus 4, so 24 newtons. So that's how you'd actually solve this problem. And this is a very typical force problem. Now, on your final, I didn't put anything even close to this difficult, but this will be helpful for those of you who are interested in passing the AP test. So hopefully this is helpful, and make sure you study the practice Google form, because those are the types of questions that you'll see on your final. But this is good review as well.